Jed, nice. Congratulations. Made it time? Yeah. I even started a little late today. Lovely music. Who is this? This is Respiro by Cone Alma. And it's definitely not being played through Spotify, but if it was being played through Spotify, you would probably use this playlist. All right, so we're still on chapter 3. Wait. Am I even on? Yeah, I am on chapter 3. Okay, yeah. Where did I leave off? Somewhere around here, I think. I definitely did this. Ludo. I mean, I can send you a screenshot of what I'm looking at. I don't see that person's name listed on this, but yeah, I mean, if you don't screenshot the thing that I'm seeing, I can like send you one, but I'm not sure what else to say. I feel like I did this. What are they trying to say with this? If x commutes with a, then x has to commute with a to the k, and the converse would not be true, because if a to the k commutes with x, x doesn't have to commute with a. Okay, yeah. Yo, Joker, how's it going? Let me bring up Penn's reading group channel and see what else is good to do. So that was 37, so 38, 39, 40. I mean, we're kind of just basically going down the list. Yeah, I mean, we're basically just going down the list here. Probably not bad to do. No, this is abstract algebra. What, I'm on page 94. Penn Center is doing a reading group for this book. And I've been reading along. I've been behind in pace, so the actual reading group's a little bit ahead of where I am. But yeah, I've been studying abstract algebra as kind of like a filler thing while I wait to see if someone in chat has a question. Given how long my stream has been for the last month or so. It's been nice to have this as a filler because trying to get questions off the internet can be really lame sometimes. So let's take a look at 38. Let G be an abelian group and H be all X in G if the order of X is odd. Okay, yeah, prove that H is a subgroup of G. Data management and algebra combined? I don't know that this book has any data management, or like what do you mean by that? Some way of thinking? Okay. G is abelian and H is all odd orders of G. Well, the identity is order 1, so that's definitely going to be an H. Good morning, Algestuki. Or should I say Kombinastuki? I don't know. How's it going? This one, I guess I gotta play around with it a bit. Can try for 1-step or 2-step. I'm not really sure yet. Okay. Pretty good. Woke up quite late, so you're still punchy. That's fair. Like, I feel like I'm waking up late, and I really don't like my sleeping schedule, but it sounds like your sleeping schedule is like much worse from a little bit that I know of. I'm just waking up at like 10 in the morning or something like that, which I don't like already, but and even then, I don't get out of bed until like 11 sometimes, which is bad. Okay, so G is abelian. H is all X in G such that the order of X is odd. Immediately, we know that G has an identity. The order of E is 1. So E is in H. So H is non-empty. This feels like something we can maybe pull off a 1 group or 1-step subgroup. So let's let AB belong to H. It's because we know it's not empty. And what do we want to, like, I guess we would start off with maybe an obvious statement, AB equals AB. And we need to get we also know that AB is an H. We want to get basically some version of AB inverse being an H. So if we could do AB equals BA because we know it's abelian. I don't know if that'll help us or not. If we I don't know if we actually have that as like a theorem or something, but I assume that a subgroup of an abelian, if you take a subgroup of an abelian group, every subgroup has to be abelian also. I think that's reasonable enough to just say. You know, there should be a way to do this. I'm just not quite seeing it. Like, I'd want to get something like, if we know that A and B are in H, and that AB and BA are in H, we should be able to get that, like, AB inverse is equal to some combination of A's and B's, and that's sufficient to prove. Jed, E means the identity of a group, and the like absolute value is actually the order, which I don't know if I actually explained that to you the last time we were talking about it, but the order of an, okay, well, the order of a group, let me actually, the order of a group G is the number of elements in G. But the order of E is different, and I'll get to that in a second. Order of an element, we'll just say A is in G, say the absolute value of A, or just the order of A, is we'll say it's just equal to n, where a to the n equals e. So basically, how many times you raise it to itself, or like, you know, what power of n gets you back to the identity. And if there is no such n, like then you say the order is infinite. If it cycles back around, though, then you get an actual thing. You get an actual like value for n. Oh yeah, shoot! I need to use that the order is odd here, in some way. Hey, Dr. L. That's the most, yeah. Dr. L. I completely agree with like that joke. That if you're talking like in terms of communication to the public, the word algebra for this topic is a terrible term. I don't get to know why things like the word algebra is used so much. Like linear algebra has the exact same issue. So I don't know exactly why they do that, but when I took a linear algebra class, I was in for a rude surprise about what the class was actually about. Draw that like Picasso and you're good. Yeah. So wait till we get into cubism algebra. The order, okay, so maybe we should start off with something different. Maybe we should say that, what should we say? Like we could say a to the 2n plus 1 is e, and that b to the 2, I should have done m first, but who cares? N and m are integers, positive, or 0. God dang it. This is so stupid. Okay, fine. I'm just saying integers, and you can fight me if you feel different. I could say whole numbers, I'm gonna guess. Hey, underscore. Al-Kashi? Really? I I learned that he was literally a dude named Al-Jabbar. And he's the one who preserved the Greek texts about algebra, or something like the ancient Greeks did a bunch of math stuff, and Middle Eastern scholars preserved it, and the Greeks lost it in a bunch of wars. So there's this like kind of like exchange where the Greeks like basically stored their knowledge in the Middle East, if you want to call that, and the Middle East like gave it back centuries later or something like that. And Al-Jabbar is the person who preserved the algebra bits. That's an interesting little thing though, Jed. And hello to Archimedes. Welcome in. So I don't know if this is going to be particularly helpful, but let's just kind of blindly multiply these things together. Now what? What we want is A times B inverse if we want to do the one-step test. I feel like it's going to be easier as a two-step. Maybe I should stop trying for one step here, because I think I can see the idea for at least part of the two-step. The one step I'm just not seeing. Okay, so if we're going to do a two-step test instead, let's work on closure. N plus 1 equals E, B to N plus 1 equals E, where M and N are integers, let's say. Oh, you know what? If I make it minus 1, I can say positive integers, right? Let's do that. Okay. So we want to show closure. Now we want to multiply these. 2n minus 1, b to the 2n minus 1 equals e. And how can we combine these? Can we say that like m is greater than n or something like that? Hey, Maxi. There's some math preserved in the Middle East while being lost in Europe. I believe sometimes the elements are like this. Oh yeah, Maxi, 100%. I'm a little bit rusty in my like history of math, the class that I took, but it's very like European centered the way that it was taught, with kind of like more, or at least the way the class structure is mostly focused on like European, but there were a few like references to worldwide math people, like I'm gonna mispronounce it, but Ramanujan. I forget his name, but the dude in China who found a really good approximation for pi using like a 10,000 sided polygon. I guess two of them, one for the inside of the circle, one for the outside of the circle. But yeah, I'm not like, yeah, even my knowledge of the European centered stuff is sketchy, and my knowledge of not Europe is much worse. So I'm gonna say maybe like without loss of generality, let m be greater than n. I think we'll like combine a and b, but we're gonna have like some slack. So if that's an odd number, that's an odd number. We want to get it so like they're both 2n minus 1, and any leftover a we're going to split out to the right or left. So it'll be 2n minus 1 minus 2n minus 1, confusingly. I feel like I'm maybe cooking a little too hard here, but to the 2n minus 1 like that. And hopefully this gives us an odd... Actually, what is this doing? I need to be right back. Sorry. Ugh, just a dude going door to door, trying to sell stuff. Okay, wait, what's happening in chat? Do the powers get multiplied? Then what is AB? Or we could just like examine those two in a vacuum, I guess. Okay. Maybe, oh, that's what you mean. Because I think the direction my thing, actually, I don't know the direction. I'm getting like a to an even power times ab to an odd power, and that doesn't really mean anything, does it? Or I don't know what you do with that anyway. So maybe Maxi's idea is better here, just examining what AB to those two things multiplied means, and not trying to set it equal to anything quite yet. So just without a plan in particular for what we're going to do with it, let's look at what AB in parentheses to the power of 2m minus 1 times 2n minus 1 is. We do know that we're abelian. So we can kind of arrange these powers however we want. Oh, I get it. Okay, that's the key right there. Because it's abelian, we can write this as a to the 2m minus 1 times 2n minus 1 times b to the same power, which would not work if we weren't abelian. And then we know that actually we don't even need that m greater than n statement now. We know that a to the 2m minus 1 is already e. And then e to the 2n minus 1 is still just e. We can write it in this episode. And we can do the same thing here, but we do b to the 2n minus 1, get 2m minus 1 equals e. So, wait, An odd number times an odd number, that's still odd, right? Because we're not bringing in a factor of 2. Yeah. Okay. So the order of AB is 2m minus 1 times 2n minus 1, which is odd. So we are closed. Let's call him that Maxi. Hey, Bagula. We're doing some more algebra. Oh, wait, really? Oh, yeah, you're right, you're right. It does prove the order is odd. We didn't prove the order is that. Yeah, Maxi's awesome. Okay. So, the order of AB, how should we express this? We know that 2m minus 1 times 2n plus 1 is a multiple of the order. So, I mean, we can't just stick a k in front of it, which would be nice. Okay. We can say instead this is going to be kind of sloppy notation because I'm going to say the order of AB divides, but it's just a bunch of vertical bars. 2m minus 1 times 2n minus 1. So the order of AB is odd, and AB is an H. Okay. So we do need to get to inverses. Yeah. If we're doing this two-step thing. Because the one step I couldn't quite figure out. So well, I mean, here, if we just we already have that the order of A is equal to the order of A inverse. Since the order of A is odd, A inverse belongs to H. I feel like that's all we need, right? Hard algebra? Yeah. Is there soft algebra? Oh God. Depends how you feel about it, I guess. I guess let's just look at 39. G being a Abelian group, X is 1 or even. But this is just a counterexample. It's not necessarily a subgroup. How would we defeat this? I assume you want like not a power of 2. Or maybe we can do it with the 1, because can we do like addition mod n? Would that defeat it? Phase planes are hard? Yeah, especially the type that you're doing. Like, when I was looking back through my notes, like, there's some really cool looking graphs that I don't remember at all how I got. Where you have, like, your normal real two, like, distinct eigenvectors over here, and you have solutions like, you know, doing that kind of thing. But then over here to the side, you got this spiral happening from some complex, like, stuff over in this, like, local area. I don't know. I don't remember how you do it. I know that you make, like, approximations for different, like, regions or something, but, like, I don't know. I remember, like, this being one of my favorite things to do in math, but it definitely looks crazy. And it is crazy. Never seen it separated? Yeah, I think that was... I forget exactly why that happened. Or I might just be crazy misinterpreting my old notes too. But I do feel like I vaguely remember making... For non-linear systems of differential equations, you can get, like, locally convergent solutions or something. I forget what the term they use is, or locally linear. Yeah, I think locally linear. So that's why you get, like, two completely different graphs, like, or phase planes, like, side by side on the same plane. I think, anyway. I'm sure it's possible, so somehow, yeah. I just don't want to dig back through my old notes again, because I'm going to feel bad again about all the stuff that I forgot. So we're saying... H is all x to g, x that belongs to g, such that x equals 1, or... Wait, x itself is even, not the order? Oh, no, the order of x. Oh, I misinterpreted this. The order of x is 1 or even. How can we break this? Is g abelian again? It is. So we have to keep with abelian groups. Memorize the pendulum phase plane, hope they ask for that one. I mean, that's not a bad strategy. That's what I did for my English classes, where, like, there's a list of books that they might ask about. I just went hard on knowing one and hoped for the best, and it worked out for me at least. So I guess let's just let's investigate addition mod n. Let's take addition maybe mod 7. And look at what h would be in this case. I feel we might have to do multiplication, but let's just stick with this for now. So the order of 0 is 1. The order of 1 is 7. So that's not in. Oh god. What is the order of 2? 2, 4, 6, 8. Oh yeah, okay. So 8 becomes 1. 3, 5, 7. That's 7. Really? Huh. 2 isn't in. How about 3? 3, 6, 9 becomes 2. 5, 8 becomes 1. 4, 7. 7. The hell? Wait, I didn't put 0 on this. 4? Hey, columns. Zone is saying try Z6. Oh, prime is a bad idea? Okay. Oh, I tried to help Oak Spear before, and they're doing stuff that I've done, but I don't remember at all. It's like Lyapunov stability, if I remember right. And I think it's awesome. I just don't remember it well enough. All right, so let's take chat advice and do Z6. 0 is certainly in because the order is 1. The order of 1 is 6. I hope that's safe to say. The order of 2 is 3, which is odd. The order of 3 is 2, which is even. The order of 4, I assume it's going to be odd. Let's check. 4, 8 becomes 2, 6. Yeah, that's order 3. 5, 10 becomes 4. 9 becomes 3. 8 becomes 2. 7 becomes 1. And then on the 6th one, okay, so 5 is in here. Now we have to look for things that don't have an inverse or things that can break closure. One plus 3 is 4. Ah. It's not closed. Okay. Just to mention the reason previous argument doesn't work is that A dividing even does not mean that A is even. The previous argument, like for 38, Maxi, was there something that I did wrong? Closure, closant. The exercise about generators of Z sub n? I don't know. I can look back around in the, whatchamacallit, the questions. Hey, Fenbucks. Everything's right? Okay, good. Let me show Oak Spirit's question. Oh, wait. This is someone else who posted something. I'll read that later. You don't have it? Oh, okay, no worries at all. I saw there was something new in my Discord and I assumed it was you, but it's actually something else. Theorem for the odd case does not generalize to the even case. Oh, really? I should probably think about that then. The odd case doesn't generalize to the even case. Oh, because you're saying like the version between 38 and 39. H does not include 1. Really? Oh, because the order is 7. Oops. Okay, so underscore asks if we already did something about generators of Z sub n. The more I think about it, the more I feel like we haven't, but let's see. It would be in chapter 3 if we have. Oh, I mean, we did do 24 and 25. The order of E is not even. Yeah, right. But I don't know what I was about to say, to be honest. I lost my train of thought. I'm trying to do two different things at once. It's not working out for me. I guess we haven't done something about generators for Z sub n, unless you want to count like those 24 and 25. Then we're spending like an hour at least on just debating what actually counts as a proof here. But I think it was for 24. Where was I? All right, so we just did 39. Let's get 40. Either a cubed doesn't equal b, or a squared doesn't equal b squared. I remember seeing Penn Center do this one, and they weren't. And I remember people asking if it was exclusive or inclusive. I feel like can't these both be true? If you have like a squared equals b cubed. Either or is a bad way to phrase this, yeah. Because I feel like exclusive or like that has to be right out. But I feel like I'm misinterpreting it because I feel like they were doing it as exclusive or. That's true. Either that, a squared doesn't, or maybe I'm only thinking about it in the reverse. Maybe the not equals 2 is maybe what's messing me up. I need to like un-De Morgan's law this. Like, can we make it into not a squared equals b squared and a cubed equals b cubed in parentheses? Like a squared, it can't be that a squared equals b squared and a cubed equals b cubed simultaneously. I think is the way that makes more sense to me to think about this. So basically just un-De Morgansing it. Or, you know, going from, usually De Morgan's present in like the opposite direction. So we could assume the opposite and say that they're both true and try to get a contradiction. And I assume we would somehow show that they're not distinct if this is true. De Morgan's are 4 different theorems, really? I don't even remember that. You're probably right. I just don't remember them that well. Oh yeah, because they show both directions, I guess, or yeah. I mean, you can do it for like if you have not parentheses and or not parentheses or. There's 2 different cases there, and maybe they even do like the reverse direction too as separate. It's not that important, but like. Anyway, I think we have an idea of how we can tackle 40 here, so let's try it. 8 different things. You count the one for sets and the one for propositions. Okay. Yeah, I first learned about it in the context of propositions. Prove I'm gonna say not a squared equals b squared and a cubed equals b cubed. That just makes so much more sense to me if I do it like that with like propositional logic syntax. By way of contradiction, let's pull an enigma here. Assume a squared equals b squared and a cubed equals b cubed. And we want to, the condition that we have to violate here is that a and b are distinct elements. So like my first instinct here is to take a squared equals b squared, and I guess we can left multiply each side by a. I don't know that it makes a big difference. And then we can say that a cubed equals b cubed. And then we can right multiply by b inverse twice to get b equals a. But a and b are distinct. I can't spell distinct. There. Okay. Let's get 41. Let S be a subset of a group and let H be the intersection of all subgroups of G that contain S. What? Let S be a subset of a group and let H be the intersection of all subgroups of G. Is S a subset of G? Or is S a subset of some completely unrelated group, potentially? What is... I don't know this question I was asking yet. Or like what the setup is. S is a subset of a group, and let H be the intersection of all subgroups of G that contain S. And mostly the same group, yeah, 10 bucks, you're right. Otherwise, it's definitely... it wouldn't make sense to me, at least. Oh, I see that Oak Spirit posted an example of their question. I'm going to show it on stream in case anyone wants to engage on it. I don't remember this well enough to help myself, but if anyone is good with Lyapunov stability, then Oak Spirit on Twitch or in my Discord in the math homework help forum, Leo could use some help with this, so. I'll show it for like another minute or so, and then we'll go back to the algebra. Actually, I'll read through it myself because I'm kind of like curious. Man, it could be a fun question, but yeah. Okay, so I'm gonna go back to the algebra, but just calm down in case anyone does know that stuff. So it's long when there are like 6 more parts. Oh geez. And hello to Mish over on YouTube. Let S be a subset of a group, and let H be the intersection of subgroups of G that contain S. You're struggling with ln functions? Oh, I mean, I can definitely help out with that. Do you have a question that you can give me to work through, or what do you want to know about ln? S be a subset of a group, and let H be the intersection of all subgroups of S of G that contain S. Prove that the subgroup generated by S is equal to H. So this feels like a rephrasing of the idea that the subgroup generated by S is the smallest subset possible. How to study the variation of the ln function? Are you talking about like function transformations? Like if you want to shift it to the right or left or up or down or stretch it? Or do you mean a different thing with variation there? Or maybe you mean identities? Yeah, I'm sorry, Mish. There's like a few different ways I can interpret that. So I'm trying to figure out which one you mean, I guess. And and I know it's not easy to describe. Hi, hey, Selenia. How's it going? This one, for example, g of x equals x squared minus 2 ln x. Okay, so what do you have to do with that? Like, just graph it? Selenia, what I have up right now is an abstract algebra textbook that I've been studying out of just as kind of like filler. We might switch gears in just a second as soon as I get clarity on a question from the YouTube chat. We might be talking about the ln function here in a minute. The subgroup generated by S is equal to H. So algebra is fun until it isn't. Yeah. For me, I think that point is pretty early on, but I think it's good to know, so I'm just dealing with it. So yeah, Mish, like I guess let me know what you have to do with that. And I'll type in text too, just in case it's easier for you to read rather than listening. So I guess to tackle A, my instinct is to do the whole set equality, like, you know, standard thing for set equality. Hey, Phobos, yeah. And prove the subgroup generated by S is a subset of H, and then H is a subset of the subgroup generated by S. I don't know how else we could possibly tackle this question. I think S being a subset, or sorry, H being a subset of S is kind of follows pretty directly from the definition of H. But the other direction, I'm trying to figure out how I'm going to do that. Start with the supposition with letting an element belong to the subgroup generated by S or H. And all right, let's just start writing. Study the sense of variation and then determine the sign of g of x. Oh, that's kind of an interesting problem. Okay, so actually I'm going to address Misha's question before I tackle 41. So it sounds like, Mish, you have the function x squared minus 2 ln x, and you need to kind of generally figure out which function is stronger and what the sign overall is going to be on 0 to infinity, positive infinity. So let's talk about that first before I do this. It's like you're talking about like the long-term behavior of functions, like maybe it's like a pre-calc type question. So I remember, at least in my pre-calc class, we didn't do limits, but we did like end bit behavior. Just kind of thinking about functions in an intuitive way without doing too many actual calculations. So your function g of x is x squared minus 2 ln x. So I'd say that we split this up into two and graph each of the parts separately, and that'll kind of give us a sense of what's happening in their combined version. So x squared is just a parabola facing up with the vertex at the origin. And what is minus 2 ln x? That's actually a good question. Or, sorry, we want just 2 ln x. The minus we'll deal with later. And so that actually makes it a bit easier for me to like picture in my head, but any log graph in general, I just kind of vaguely draw like this. And I'll even call it 2 ln x because it's not, I'm not like labeling any points or anything anyway. So I think the idea of this problem is that we can see that x squared, it blows up to infinity pretty dang quick. Like it's pointing up is the point here. And it's like increasingly pointing up. Whereas ln x, it is pointing up and it will always point up, but it's also leveling off. Like it's becoming almost horizontal, but not quite. So in the long run, as we go way up, like off to positive infinity, which is like going to the right on the graph, this function is going to like, you know, blow up higher and higher, and this function is only going to barely increase at all. It will increase just barely, especially when compared to a parabola. So what we're actually doing in g of x is taking the parabola and subtracting out the log. And really the parabola is going to be the main part of the story here. I'm gonna like section off the early values of x because that part's a little bit weird, but in the long run, I really expect this graph to basically be a parabola that just doesn't increase quite as much. Because, you know, again, the parabola is increasing super fast, and 2ln x, it's barely increasing at all. So the parabola is going to be like the much stronger function here, we might say. I sectioned off the values of x between 0 and some, like, you know, small number, because that goes to negative infinity and that becomes 0. So I guess it would be, if we did want to draw that, close to 0, the ln x is pretty strong. So you could say something like that, maybe. But that's kind of how I would analyze these functions. And actually, let me check my work in Desmos too. It goes to plus infinity as x to 0? Wait, really? Oh, shoot! You're right. I'm being corrected from chat. I got tripped up because of the whole sign issue. So I graphed positive 2 ln x, but it is x squared minus 2 ln x. So if it goes off to negative infinity here, when you subtract a negative infinity, you do get positive infinity. So technically it's pointing up. So it's gonna be something parabola-like, but I'd say like this end, like there is a vertical asymptote at x equals 0 because ln x isn't defined there. It'll be like a lopsided parabola, I guess. That's been shifted. Hey, hoo-hoo. How you feeling? Thank you both for that save there. Phobos and Maxi. Better? Oh, that's great to hear, hoo-hoo. It always sucks being sick. What is x squared minus 2 ln x looking like these days? Yeah, okay. With that little correction, it's really a big correction. I did call it where it's kind of an asymmetric parabola. Between 0 and 1, the ln x is very strong. It's very big values, and the parabola is very small. So the ln x kind of takes over. And since we're subtracting it, it goes up to positive infinity. And then after x equals 1, the parabola is much stronger, and it takes over. So it looks more like a parabola. First proof limit can be done fairly easily using L'Hopital's. Right. I forget how you deal with the infinity minus infinity case. I know you can deal with it. I forget. It's not as simple as like doing... Yeah, I forget exactly how you like split up to get into a fraction, but I know you can. Could you also make a table of variation of the function? By table of variation, do you mean like plugging in values for x and seeing what y is? You definitely could. I think that would be a huge pain to do by hand because you said yes. Okay. So yeah, I mean, you technically could, but unless you have a calculator, good luck getting values because it's very hard to get values for ln. Like if you want me to do it? I'll show you why it's hard. if you're not allowed to use a calculator, it's not going to be easy. I'm going to split the function up into like I'm going to make a bunch of columns here to make the calculations a bit cleaner. Well, the calculations that we can do anyway. So I made a column just for x squared, a column just for 2 ln x, and then a column for the 2's subtracted. So the reason I'm saying that you can is because you can absolutely plug values in for x here. That's the entire point of having a function. We can't plug in x equals 0, but we do know that, or we should plug in values between 0 and 1. So let's say like 1/2. X squared is 1/4, but then here's where we run into issues, because you can't calculate 2 times ln of 1/2 easily by hand. So if you have a calculator, then go ahead and plug that in, and you can make a table all day. But if you don't, then this isn't really going to help you out that much. Oh, I mean, you could plug in E, I guess, yeah. But yeah, you're gonna have a problem getting values for the parabola. Like, you could definitely just like estimate it and get something that's good enough for the graph. I agree, but my puny brain craves them for graph drawing. Yeah, I mean, my best recommendation for you is to get comfortable doing this sort of analysis up here, just with the general behavior of the functions, and not be so reliant on getting actual values. Because if you already are allowed to use a calculator, I assume you're allowed to use a graphing calculator, and if you have a graphing calculator, you can just plug the graph of that in directly. If you're forced to use a scientific calculator or something, then like, yeah, we can go into this more, but like this technique I don't particularly recommend if all you need is is to describe the general behavior of the function without actual values. But yeah, if you do insist on making a table, just make sure you plug in, you think about how the functions actually, like the initial two functions actually behave, and make sure you plug in values that are likely to show you the full behavior of the function. Like, don't just start from x equals 1 here, because that's going to miss this entire bit of the ln function that goes all the way down to negative infinity. So I might even do a couple of fractions, like 1/2, 1/4, 1/8, and then 1, and then do like, 1, 2, 3, 4, 5. Or you probably don't need that many points, but for the parabola is kind of okay with everything, but ln has this kind of very different behavior depending on your value of x. So you want to make sure that you like accurately capture all that behavior, and that you don't get baited into just doing the easy points like 1, 2, 3. Let's have at least 8 decimal points before you're satisfied. Oh God. So yeah, Mish, I think that's as far as I, can really take that problem without doing a bunch of tedious calculations. But I hope that makes sense to you, and that kind of like helps you know what to do. But I also don't want to sit here and plug in 2 times ln of 1/2, 2 times ln of 4, 2 times ln of 8. It's just going to take a little bit more time than I want to spend right now. I'm going to erase the problem on the board in a second so I can get back to the other problem. But let me know if you have any questions on that, or if you have any questions on like another topic, I guess. Okay, so I haven't looked at part B yet. I don't think I want to look at part B yet. Let's just focus on part A. Okay. So our goal here is to prove that the subset generated by S is equal to H. So we'll start by letting A belong to H, and we want to show that H is a subset of the subgroup generated by S. And I'm choosing this one first because I think it's going to be the easy. I should do lowercase h, right? That makes more sense. There's a table of signs. Oh, Mish, maybe I misinterpreted like only the positive or negative part. Oh, okay. Yeah, if we're talking about positive or negative, that's a lot simpler to do. So actually, I'll quickly like show that too. If you want to look at just the signs of this function and where they might change, look at where the sign of each individual part of the function changes. Oops, that's 2 ln x. And sign changes happen potentially when x equals 0. So we have our parabola again. We have our 2 ln x again. So we have I didn't draw it right, but we have a 0 here that we need to examine, and we have a 0 here that we need to examine. So x squared, it's just always positive or 0. It doesn't actually change sign at this 0. So we don't really get anything that we need to check from the parabola part. But we do see that 2 ln x, it definitely changes signs at x equals 1 is what that's going to be. Because ln of 1 is 0. So if we're going to make a sign chart here, we'd want to, it gets represented in different ways. I think the more common way is to do it like a one-dimensional line here. And actually, so let's plot, on this line, let's plot 0, and let's plot 1. From 0 inclusive all the way up to negative infinity, we don't get anything. The function isn't defined there because ln isn't defined for 0 or negative numbers. Between 0 and 1, we get huge negative numbers because it's minus, nope. We get huge positive numbers because we're subtracting a very large negative number, and subtracting a negative is the same as adding a positive. So, and x squared is always positive, so positive plus a positive is positive. And then after x equals 1, we still have a positive from the parabola, and 2 ln x, it turns positive, and remember that we're subtracting it. So this is something where it might be better actually to just graph the minus 2 ln x, since I've obviously been making mistakes with this, but just to go with this construction, where we have a very big positive number minus a very small positive number, because remember x squared grows so much faster than ln x. So I'd say that we're also positive over here to the right of 1. So here we just happen to always get positive. That matches with the graph that we made on Desmos. This is kind of a rough way of doing it too. You could have just like a tiny little dip into negative and then come back up, but this is kind of like the rough way that you would do it. You look at the zeros of each part of the function and you check things in between those zeros. Reject pre-calc, embrace algebra. Yeah, Celine, yeah. So that makes sense, Mish. Yeah, Celine, thankfully we do have that the intersection, or we proved, I think in the last time I streamed this, that the intersection of two subgroups is still a subgroup. It's actually a simpler way to do it. Simpler than this? I'm not aware of it, but if you want to talk about it, let me know what that way is. The simplest way is just a graphing calculator, but of course that doesn't help you if you're not supposed to use one. Maybe because I'm just French. Yeah, maybe. Like I'm a American, of course, and things definitely do get taught differently over there. So we may have been taught different ways to do the same thing. So yeah, I mean, if there's a simpler way and you want to see me try and work through it, or if it'd help you, then let me know. But that's the way that kind of I was taught to think about these problems. Okay, so I'm working on H is a subset of subgroup generated by S, and H is defined as the intersection of all subgroups of G that contain S. Is this the easy direction, or is it actually the reverse direction that's easy? I think it's the reverse direction that's easy. Now that I think about it more. So let small s belong to the subgroup generated by S. Since H... Oh wait, that contain... Oh wait. Yeah, that's the thing, but thank you. Yeah, Mish. Glad as I will be able to help, like, hopefully I helped out at least a bit. And thank you for the question. And hello to Spam Hacker over on YouTube. So I did just notice that H is the intersection of all subgroups that contain just S, not the subgroup generated by S. So maybe... Maybe I need to see what theorems we have already, or what facts we have. That's the exact fact that I want to look for, Federico. Because I remember the book saying that somewhere. But I feel like I should look at it. Hey, Gold. Super, yeah. I've been reading along with Penn Center's Abstract Algebra reading group. It's kind of been my like filler content for if there aren't questions from chat. Yeah. So I'm like a little bit behind, but I'm learning this for the first time, so I'm just kind of taking my time with it. We're just on what, chapter 3 of this book? Yeah. This edition does explain it, but I think the explanation sucks. I did not understand it in the slightest. I had to look at the examples and like reverse engineer it for a set. I think I need to scroll further up. Okay, for any element A of a group G, this will think of subgroup generated by A as a small subgroup of G containing A. I feel like this should be much more emphasized. But I think it's fair game to use this fact. They don't, I guess they don't say what's smallest. I guess they can go by order. Oh, Finbox took a look at that one. Oak Spirit, if you're still around. I might take a screenshot of that and put it in the Discord too if Oak Spirit isn't still around. That's okay with you, Finbox. Okay, Oak Spirit, it is here. So if we're saying I think we still need to do this subset of each other thing though, right? It should be pretty quick. Okay, so maybe I want to do oh, we're gonna actually have to name an element for one of these directions. Oh, what? No, I hit the wrong key. Ah. Come back. Okay, so the subgroup generated by S is the smallest subgroup containing S. Since S is a subset of H by definition, the subgroup generated by S, I guess we should say inequality now, because we're in group mode with this. So H definitely contains a subgroup generated by S. Can we now make the claim that the subgroup generated by S contains H? And that'll get us where we want to go. For this one, Oh, well, Federico, I'm still working through A. I think I've only proved one part of it. I'll look at that in a second, though. I should actually label it as A, right? H definitely contains S, but I think we need to do the opposite. Or I need to do the opposite. And I feel like the whole intersection thing is going to be key here. Let H belong to H, since H is the intersection of all subsets containing S, H belongs to S. Like, the idea is that if H didn't belong to S, the intersections would get rid of it. Because any other subgroup, like H isn't going to be in some other thing that's not in S. I don't know if this is, I feel like this, it's not rigorous, but that's maybe good enough. Intersection overall is the smallest? Oh, okay. You missed class on Sunday though, no one tell Penn? Ooh. You're gonna miss out on attendance points. Okay, so what does B even say? I haven't even looked at B yet. If S is not empty, prove that the subgroup generated by S is equal to S1 to the N1. What is N? So S sub I is the ith element of S, I guess we can say. That B makes zero sense to me. What is B saying? Like, is N sub 1, N sub 2 some random power of S? Is it the order of S? That wouldn't make sense, I guess. You're saying yes, I assume, to being some random power. Or maybe you're saying yes to Selena's question. Some random power? Okay. Now, this is... This is just multiplication. So isn't this entire thing, like, or isn't this just a single number? Or a single element of S? Well, I guess we have this iteration thing? No? But it's all like, I feel like all the iteration is done, and then you define the set. If S is uncountably infinite? Oh, I need to figure out what this is saying before I can even think about that. You study in Rome. Ooh, that's cool. The subgroup generated by S is equal to some random power of S sub 1 times some other random power of S sub 2. Once you choose an M, all the Si and Ni, then yeah, it's like a single element. You're allowed to make those choices freely. So the point is that the subgroup generated by S has to be equal to all of those single elements at once? This step order notation makes no sense to me, I guess. I almost feel like the order should be reversed, where we're naming, like, for all M in a certain range, and for all S sub I and N sub I. Like, I feel like that part should almost come first to actually get this iteration thing happening. Although I don't think the question is wrong, I think I just don't understand it. So... No, it's weird. I feel like we at least need a comma here or something, or like if this... Okay, wait. Maybe this is that linear combination. I think this is that linear combination idea. When you have a subgroup generated by multiple elements. Where you take every possible power of every possible element and combine them. Now, I'm still weirded the hell out at the notation and it resulting in just a single element, which feels very wrong to me. But I'm willing to chalk that up to me not knowing the notation well enough, I guess. And maybe I have the idea, and that's enough to do the proof. Oh, and thank you, Fenvox, for taking a look at Oak Spirit's question. Definitely were able to say more about it than I could, so I appreciate it. Okay, prove the subgroup generated by S. I mean, isn't this like a definition thing? How? Like, I thought this was just how S is defined, not something that you would prove. They need a period here. If H is any subgroup of U containing S, then H also contains S. Oh, so maybe we have to build from this to that linear combination thing. And I'm saying linear combination meaning powers, not coefficients, I guess. Which is, it's probably a terrible term to use, but okay. So yeah, Federico, I think I've gotten to that point of understanding what the question is asking. Where they're basically describing, like, in Z20, these elements can all be derived from, like, combinations of powers of 8 and 14. And that's what that whole S1, S2, S3 thing is. Should I from part A? Sure. Let me just like scroll down and get the question back up again. I kind of just used definitions from the book. Or like, the book didn't really give it didn't give like a boxed definition of things, but like, it kind of made some claims that I just used freely. Should be able to check that the right-hand side set is a group. Hmm. Yeah, chill 2-year masters. Ooh, nice. I mean, really the whole subgroup generated by S equals H thing is kind of like the book just says that, like as a definition. H is the subset of all subgroups. Does that change? Does it? Yeah, I'm not sure I know what the potential issue is, Phobos. I would believe it if there was one, but um into Federigo, yeah, we definitely proved that the intersection. Wait, yes, the intersection of subgroups is a subgroup. Change fields to computer science. Oh wow. So for I don't know. The 41 is kind of a weird question to me. I'm going to look at the back of the book at the end of this one to see what they were intending. For B, Federico was saying that we just need to prove that the right-hand side constitutes a group. Which, honestly, I'm still kind of short. Like, I'm still struggling with the actual meaning of the right-hand side. On one hand, I feel like I know it. On the other hand, I feel like I don't know enough to actually, like, I assume we're going to need that to do a proof. So if we want to prove that it's a group, we show it's closed, associative, like, I guess we go back to like that basic thing, but closure would be like the biggest thing, I think. Associativity just be inherited. Identity is certainly in there. And inverses. I mean, they should be in there. You know what? I'm just gonna look at the back of the book for this one. This is a. I think I don't understand what the book's intention is with this question. The entire thing of subgroups generated by a set, I have not been a fan of the book's explanation for, and I'm not sure what they want me to do with this. So we're chapter 3, number 41. All right, here we are. Okay. First observe that because S is a subset, or wait, okay. I'm reading like this thing here. First observe that because the subgroup generated by S is a subgroup of G containing S, it is a member of the intersection. So H is a subset of the subgroup generated by S. Okay, fair. Since H is a subgroup of G and H contains S, by definition, okay. So that's where they use that kind of like small subgroup idea. Okay, so I feel like I did A more or less properly. I could have phrased it better, but I think I have the idea of A. For B, this is the same exact thing, but they're calling it K now? Okay, sure. K satisfies the subgroup test and contains S. What? Okay, I did think about how we could just do a subgroup test rather than the original test for groups. Closure, I feel pretty convinced that it's closed because every by definition has every possible multiplication of the elements. For inverses, that's covered because n sub I is any integer. And it does contain S. So the subgroup generated by S is a subgroup K. Subset, subgroup, subset. Wait. This should be less than or equal to, not a subset. By the notation the book was using. Anyway, on the other hand, if L is any subgroup of G that contains S, then L also contains K by closure. Closure. Okay, sure. Thus, by part A, H equals a subgroup generated by S contains K. This is the phrasing of this is kind of weird to me. It's trying my head around it. Joe, hope the move went well. Thoughts on the Fallout show? That's a very well-timed question because I watched the entire thing yesterday from episode 1 to episode 8. There were... Overall, I really like it. There are parts that I found to be cheesy and cliche, but in the exact way that something based on Fallout should be. You're on episode 3? Okay. So, I won't say any like plot points or anything like that. What else can I say about it? There were a lot of things in the show that just really like made me smile. With they use a lot of the actual like game sound effects. That just kind of like made me nostalgic. You know, like first few episodes towards the end, it got really good. Yes. One thing that I was disappointed by, oh man, it's not a plot point, but I feel like saying something negative might like put it in your head. It's completely unrelated to the plot. I guess I'll just say it. In every like recent Fallout game, they make a huge point of right as you exit the vault at the very beginning of the game, you have this like amazing view. And just like a really like nice like landscape and something very obvious to go to at first. And like they kind of did that in the first episode, but like I don't know. I wasn't a huge fan of like what they showed. Although the pier was like cool, but it wasn't like anything significant. They make up for it in later episodes though. There's some really awesome shots that I like a lot, but it's kind of like it's like inconsistent. I guess with like the cinematography. But overall, it's like it feels like a, or this is something like in simplex what Chinko said last week. That I 100% agree with. It feels like just like a Fallout adventure you would have in game, and that's exactly what I want from a Fallout TV show. Move went good. Finally got the last little bit of boxes out. You're gonna finish the show tonight? Oh, great. It's super good, and I'm gonna probably I'm gonna start putting a new character on Fallout 76. Jose said that he would too, but like he didn't reply to me the last time that I well, and asked me if he wanted to. So I'm gonna try asking him again, but if not, I'm just gonna start like playing it off stream because I'm in the mood for Fallout now after watching that. Okay, let me see what Pen Center recommends to do next in this. Did Pen Center even recommend to do 41, or am I just being a masochist? Oh, wow, yeah. The list of questions from Pen Center skips over 41. It does recommend 42, though, so let's try that one. Fallout 76 to max level hardcore mode. Does it have a hard... Oh my god, it's been so long since I played Fallout 76. Is there like a hardcore, like, one life mode? That could be kind of cool. Hopefully it'd be like Iron Man, or like it, or like it's like hardcore Iron Man, where if you die, you still get to play your character, but... in the group Z, so just integers with addition, find the subgroup generated by 814, 813, 615, MN 812, 1845. Okay. I feel like we've already touched... I feel like we've already solved this question in previous ones. Where, we kind of figured out what covers Z and what doesn't. Today started your first run of Fallout New Vegas? Oh my god, Selenia. Favorite game of all time. It's so good. I love it. Like, the thing I love the most about the Fallout games are like the atmosphere and kind of like the world building with all the lore and stuff that's hidden around. And back to the Fallout show, I think the Fallout show captures that really well. But like that's like the number one thing that I love about Fallout. And I think New Vegas does that the best. And unfortunately, New Vegas is like the only recent Fallout that wasn't developed by Bethesda. Which the Fallout 4, I do not like Bethesda, but oh well. What can you do? Fallout 76 is good, but they're never gonna make another multiplayer Fallout, I bet, after what happened with that one. So we're finding the subgroup generated by 8, 14. And the conclusion that we came to last time we were doing questions like this was we have to worry about their GCD, or at least that's the way that I like to think about it. So it's going to be every integer that is of the form 8m plus 14n. Their GCD is 2. And we can multiply this equation through by anything we want. Can we get to 0? Yeah, we can multiply through by 0, right? Feeling good recent Fallout game. What's the one not made by Bethesda? I mean, yeah, I hate Fallout 4. And that was made by Bethesda after a super long way after Fallout New Vegas came out. Like, we're like, I think 8 years or 10 years. Fallout 76, it was terrible on release, but I think it's an amazing game now. And to Bethesda's credit, that is made by them, as far as I know at least. But no, Bethesda kind of lost my trust with Fallout 4. They make a Fallout 5 though, then I'm still buying it, but and that's just because of Fallout 76 kind of redeeming themselves a bit. Anyway, I think it's just gonna be a subgroup generated by 2. So, -4, -2, 0, 2, 4, . It's good enough for me, I think. 8 and 13, they literally give this as an example of being all integers. Like, this is a crappy. I literally remember just seeing them giving this exact question in the book, or like in the when they first gave subgroups generated by a set, they gave that exact example of just being all integers. 6, 15. That's gonna be multiples of 3. M, N. I don't know how we're gonna do this one, I guess. What I'm gonna do first is I'm gonna go pee, because I have to go pee, but I'm gonna take a quick break. 1 second. Okay, we're here. How are we gonna do this whole m comma n thing? Well, I guess we can say the GCD, right? I don't think there's a better way of saying it. It seems like the easiest thing to do to me, though. 12, 18, 45. This one's a bit trickier. So, these certainly are not relatively prime. They all have 3 in common. Is it as simple as multiples of 3, though? I feel like it shouldn't be. It's multiples of 2 and multiples of 3, right? And 9, which is just multiples of 3. Because I think we could write it 12a plus 18b plus 45c equals something. I don't know. You could always take 0 for one of these constants and only have the GCD of just 2 of those. If you have all 3 of them at the same time, what does that do for you? Like, okay, maybe what is the lowest positive number that we can make with these? Like, if we can get to 1, we can get to any number we want, right? I think that's the question here. I assume that we can, well, I already know that I can get to 2. In some way, somehow, I can get to 2. I'm just trying a bunch of things in my head right now. Beats by Dawn. Dawn does beats. I know you guys probably just love this marker clicking beat. It's really bad because I always need to fidget with my hands. In high school, I would take my pencil and I would like do the flipping through my fingers. It's a little bit hard with this marker because it's so thick, but I would try and do it really fast, and I would end up just like flinging my pencil across the room all the time, and I have to go and grab it. No one ever said anything though. Beats by Dawn goes hard. Hell yeah. Oh yeah, Joe, when do you start the new job? If I subtract like 24 from that, what do we get? 21? No, so that's 3. If I get to 18 after that. I'm going to... It's really bad. There is no relatively prime pair of numbers contained in the set. And I feel like I could make the claim that if I'm going to use linear algebra terms, that it doesn't span, I guess we can call it R1. Actually, could you literally just consider these vectors like one-dimensional vectors? Because with 12 and 18, you can make 45, right? Like, if you take any pair, you can make the third one, which is bad. That's how I'm thinking about this. You start mate 6. Oh, wait. 45 is odd. You're right. Huh. It's Vapu, a Finnish folk holiday. Went out drinking for the first time. Ooh, nice. I just lowered the cost for that one too, so you're welcome. May 6th. Okay, so that's next Monday. Ooh, good luck. So, I don't know, got to use that one. Yeah, syntax error. I remember like if I'm like really drunk, or I remember like when I got my wisdom teeth out and I was loopy from the anesthesia, I like to try to do math in my head and like limit tests. I could actually still do math. At least in my loopy state, I feel like I was doing math, like calculus, like pretty well. There has to be a way to analyze this better, right? Hmm. So if I think about pairs again, that pair is GCD 3, and if I were to combine them into one unit just as like 3 times a constant plus 12a, we still can't make every integer. The GCD of 12 and 18 is 2, and 2 and 45 are relatively prime. So maybe we do make every integer. What? Oh, it's 3. My bad. You're right. So 3 and 45 aren't relatively prime either. Are they? Oh my god. Try 6? Oh my god. It is. You know what? I'm never doing math again, dude. Oh, okay. It's 6. 6. Can we graph this? Oh, fuck me. Stay, marker. Like, I don't want to think anymore. I just want to. Fine. Take your save. I mean, I could look in the back of the book, I guess. But if I gave Wolfram Alpha this, what would it tell me? I'm kind of curious. It doesn't like any of those. You could... Oh, what if you solve it for one of the variables? Does that help you? I feel like I'm doing this backwards, where what? The GCD of 12 and 45, that is 3. And the GCD of 12 and 18 is 6, which they are relatively prime. Okay, fine. Yeah, sure, Joe. I still feel like we can't make every integer. It's just kind of tricky to actually do, because I don't know if there's some crazy combination that somehow gets you 1, right? Let me... tell me when you send it, Joe, because I have to like switch Discord profiles, so I won't see it immediately when you send it to me. Oh yeah, just see if it'll find a linear combination that gives you 1. Is it that simple, Moo? We get a plane? Oh, I guess that, yeah, that would make sense if it's a plane. What does a plane mean? What do the numbers mean, Mason? It means that there's infinitely many solutions that get us to 1? So the GCD is, so maybe what Moo was saying is right, where we just take the GCD of all 3 of them and don't think about it too hard. And the GCD of all 3, wait, isn't that 3? Solve over integer, oh nice. Yeah, you're right, these aren't necessarily integer solutions, are they? No integer solutions. Okay. So we do just get multiples of 3. Okay. Thank you, Moo. And welcome in, by the way. Let me see what Joe sent. Ooh, okay. Got some chain rule. Oh my god, that's such a mean problem, that first one. What's the second problem? Like, the first problem is just tedious. I can do it, though, and I will do it. Ooh, okay, and then they're using a... average value theorem or whatever. Same as... Oh, so everything is a multiple of 3. Oh, that's so simple, Stooky. Oh. Why did I... Okay. That's such an easy way to show this. Okay. So I guess in regards to the last part, it'd be the subgroup generated by 3. Oh my god. Okay. So I did just get DM'd a few questions. I'll copy them down onto the board. 3 divided 12, yeah. Okay. I'll start with the first one, because the first one does come first. Although I'm doubting everything that I thought I knew after failing at calculating the GCD of 12 and 18, but let's not talk about that. So this first one, looks like some Calc 1 stuff, but some really annoying Calc 1 stuff. We have to take a derivative that involves chain rule, quotient rule, product rule, and then I think chain rule a couple more times in that order. Okay, so we have to find d by dx of ln of 5x plus 8 times x plus 6 cubed over 1 minus 2x to the 6. Ugh. Make sure I copied it down right. 5x plus 8, x plus 6 cubed, 1 minus 2x to the 6. Okay. So first step, take an aspirin. Second step, let's start unpacking this. So I'm thinking first about the chain rule, because we have ln of something. So I'm going to go kind of from like the outside in. You could technically do the inside out, but I think for this one, outside in is going to be a lot cleaner. So let's, the derivative of ln of anything is the reciprocal of that thing. So I'm going to start by saying that the first part of our derivative is going to be this inside part flipped. 1 minus 2x to the 6 over 5x plus 8 times x plus 6 cubed times, now we have to do chain rule, the derivative of the original inside. I don't normally show it in this much like detail, but for I have not already made a mistake. What? Wait. Oh my god, never mind. You're right, Stooky. Oh my god, I didn't even think about that. Oh my god, I did make a mistake. That's like a bajillion saves. I didn't even think about log rules. Oh my god. Stooky, I don't know. Yeah, this is not my day for math, apparently. You're right, we have log rules. Okay. And hey, thank you for getting that, Jed. Okay, so I did make a mistake, but there's a way easier way to do this. God, I don't know why today's so bad for my brain. If you have ln of a times b, it's the same as ln of a plus ln of b. And if you have ln of a over b, it's the same as ln of a minus ln of b. So we can use these two log rules to make our lives so much easier. Oh my god, I didn't even think about having a log there. So this thing can get split up as ln of 5 plus it. 5x plus 8. You know, if 5x plus 8 is so much of a mouthful, just say all of those words at once. 5 plus 8. Plus, now we'll do ln of x plus 6. And if you have ln of a to the power of b, same as b times ln of a. Okay. So the power can come out front, and we're going to plus it. ln 3x plus 6. Oh my god, this is a million times easier. And now on the bottom, we'll do the same thing, but it's division, so we do subtraction. Minus 6 ln 1 minus 2x. Okay. This is so much easier to differentiate. How many is a bajillion again? I don't know. Shouldn't ask me. All right, so now we get to differentiate each of these three things individually. So now we get to do 1 over 5x plus 8, because that's the derivative of ln. Now derive the inside. 5x plus 8 derives to just 5. Now we come over here. The coefficient of 3 just stays the same. ln of x plus 6 derives to 1 over x plus 6, and I'll put the 3 on top. Now we'll have minus 6 over the inside, 1 minus 2x. Chain rule, 1 minus 2x derives to negative 2. So if we clean this up a bit, I'll say it's equal to 5 over 5x plus 8 plus 3 over x plus 6. 2 times negative 6 is plus 12 over 1 minus 2x. Okay, so much easier. So that's what I would do for the first one. You could technically get a common denominator and stuff, but I don't know why you would. I don't know if you want to take like a screenshot of this, Joe, or like what kind of format would be best for you, but they said, oh, cool, they're lurking. All right, so let's go to the second one now. This one, there's no identifying information here, so I'm just going to show the problem on my screen. I'm going to like show the problem on stream because I can't really explain it without looking at the problem. Just making absolutely sure there's nothing like identifying. I don't see anything, so let's bring it up on stream. Because this one, it's going to be a little bit harder to just like copy it down. Ruhan04, can you do an analysis question? If it's basic analysis, that's something that is in my wheelhouse. In general, I do what Sui says. Just ask it, and I'll tell you if I can handle it or someone in chat might be able to handle it as well. Okay, let me show this. Okay, the text is kind of small, so I'm gonna zoom in and scroll left to right as needed. For the oh. I'll think about that a bit more in a minute, Ruhan. For function f in the interval ab, the graph of f is given along with the secant line passes through the graph f, x equals a, x equals b. So our function is negative 60 over 49 x cubed from negative 2 to 2. Looks something like that. Very strange number, but I assume it's chosen carefully. Or maybe it's just random. Use the graph to make a conjecture about the values of c satisfying this equation, which is I can't remember I don't remember the name of it offhand, but that theorem. Intermediate value theorem is not that. Is it average value theorem? It might be. It's gonna bother me. Mean value theorem, that's it. Okay. The value of c. The values of c satisfying this equation. Okay. So what they want you to do, how exact do they want you to be? I guess I don't know what the options in the boxes are, but the idea of the question is you take this secant line that they draw here, and the mean value theorem says that there is at least one place between negative 2 and 2 where this is the tangent line as well. So you take the same exact line and just transfer it so like anywhere inside this interval where it would be tangent. Let me actually bring up paint. This is a good one for paint here. Okay. Oh, that's not where you should go. That's where you should go. Let me take a screenshot, copy it in. Okay. So any line that's parallel to this green line that we can draw in this interval, that would be a tangent line. So I'm going to draw in blue. I'm just going to, draw a parallel line, and then I'm going to use the arrow keys to shift it around. So I can see it looks like there's going to be one tangent line right around there, which, I mean, we could guesstimate that as 1, but it seems more like, 1 1/4 or something for the x value. Hey, Obi, how's it going? There's a second answer, though, if I paste, what? Oh, pasted the original image? Jeez, okay. Oh yeah, that's right, because I didn't copy the line. There's a second possible answer here. If we go over to the left, we can certainly get a tangent line somewhere just past a -1. Like again, it's like -1 1/4-ish for the x value. But that's basically the idea of the problem. The mean value theorem says that there should be at least one point on this interval where the secant line is parallel to the tangent line. So you take any parallel line and just shift it around left and right until it becomes tangent. And here's actually two possibilities. So let's see if we can tell from the wording of the question how they want things done. If that's, or if that's like good enough, I can move on to, but use the graph to make conjecture about the values of C satisfying this equation. Getting the computer updated, nice, nice. The value of C, maybe that's gonna be C equals something. Slope of the tangent line to the graph of f at, what? I have no idea what will go in these boxes. Tangent to the graph, probably at x equals something. This big box, I'm not sure. The slope of the secant line matches the slope of the secant line or equals? Huh. Equal to, less than, well, there's the thing on the other side though. So yeah, if you're still confused, like, or if you only can like relay it through Joe, but like, let me know if like the boxes say something that doesn't match with what I'm saying. But the idea of the question is you just take this secant line and shift it left and right. Anywhere inside this interval out, it becomes a tangent line, and that x value is what they want, where that happens. But yeah, thank you for the questions, and unless I hear anything else, I'll move on, but I'm happy to shift back if there is something more to say on it. No worries. I know why can't I ever remember these value theorems? Mean value theorem, yeah. Because there's roles, there's mean value theorem, there's intermediate value theorem. What even is roles again? Oh yeah, that there's a critical point. Okay. Awesome. Let's go to have a calculus question, because I think they're fun. Okay. Oh yeah, that one. Oh, you know what, Obi? I forgot that I had this still open, but Oak Spirit was asking about the Lyapunov stability for like nonlinear systems of differential equations. I know this is super out there, but if you do happen to know anything about this, I guess that Oak Spirit's been like trying to learn it. I think Fembox helped them out a little bit. But if you do feel so inclined to like speak on it, which you definitely don't have to, but don't know Lyapunov offhand, but you can poke around. Okay. I mean, for you to whoa, 95 new things? Oh, underscore was helping out with this one too. Okay, so I wasn't even completely up to date on all that's happened here. So maybe it has been handled. But over in my Discord, Leo is Oak Spirit's Discord name, and this is kind of like where the thread is. It's the first one in math homework help, so it sounds like it like underscore is working on this though. So it might have actually been resolved. We did Jacobi linearization. That might be, because like I did learn this at some point, and I think I remember using Jacobians. We need help though? Okay. So no obligation at all, Obi, but I know you like differential equations. Of course, this is some crazy differential equation stuff, but yeah. And thank you, underscore, for jumping in on that too. It's in regards to that D problem, you don't know anything about the manifolds part? Okay. Yeah, me neither. I don't think I even learned about manifolds when I was doing that. I don't think I've learned about any manifold in any context. I feel like it's never come up as part of my my coursework. Okay. So where were we with the abstract algebra stuff? What's next in the list? We just did 42. So looks like 45. I hope Pinson already did 45. Let's see if I recognize it. Centralize. Oh yeah, I'm pretty sure Pinson already did this one. Okay, good. So must the centralizer of an element of a group be abelian? Well, isn't the center of a group abelian by definition for the second part? I need to look back at the centralizer of an element of a group. Like, this phrasing is kind of confusing me. Let's look at center first. The center of a group is the subset of elements in G that commute with every element of G. So, yeah, I feel like that just matches, like, or the question just matches with the definition for the second part. The centralizer, though, the centralizer of A in G is a set of all elements in G that commute with A. Specifically with A, not necessarily with each other. With, like, other elements in the centralizer. Right, so the centralizer isn't necessarily abelian. It is only abelian when A is involved, which means it's not overall abelian. You take the center of the centralizer, I guess. I think the center must be abelian, because it only worries about the elements that commute with everything. Shoot, I shouldn't shake my desk. Okay. I feel like I've answered 45 then. No, and then yes. 45 through 47. Okay, so 46. Suppose A belongs to a group and the order of A is 5. Prove that C of A is equal to C of A cubed. Ooh. Find an element A from some group such that the order of A is 6. Wait, what? Oh. Okay. This is a different A now for the second part. So the centralizer of A is the same as centralizer of A cubed. Interesting. I'm not sure how we're going to do that. Let's start writing things, though. Ah, that's not what I want to do. That's what I want to do. Okay, so we know the order of A is 5. We want to show the centralizer of A is the same as the centralizer of A cubed. Oh my gosh. As part of watching all 8 episodes of the Fallout TV show yesterday, I stayed up a little too late. The centralizer of A. Is equal to centralizer of A cubed. I guess we have to do the whole subset of each other thing. I was hoping there'd be a way to avoid it for some reason, but I don't think we can. So if we let A and B belong to the centralizer of A, we have to show that if we're doing it like this, we should show that A and B are both in A cubed. It is an unfortunate consequence. Yeah. It's like I finished watching at like 12:30 at night, but I was so like hyped from it that I had energy and I didn't actually fall asleep until like 2 in the morning. I feel like this argument isn't going to be all that bad since A times A cubed equals A cubed times A is in, oh God. Actually, we can't even make a point right now that, okay. Well, let me rephrase this proof. Because we can do we can do a bit of the proof right now, or like both directions of the proof in one step. Since A times A cubed equals A cubed A is in the centralizer of A. What? Of A cubed, and A cubed is in the centralizer of A. Now we're going to let B also belong to C of A. And then what we're gonna do, so AB equals BA. But what we're gonna do is we can even just say AB equals AB. Let's multiply by A squared to get A cubed B equals A cubed B. And then we're going to make, and I remember that I made earlier in another proof that a cubed b is same as a squared times ab, and a and b commute, so we can switch just those two. And we can do the same thing with a squared, so we can to a times a, and then ab commute. And we'll get that a cubed b equals ba cubed. So, what does this prove? Wait. Oh yeah, so b is in the centralizer of a cubed. Okay. I wonder if I can just... Abusive notation? Is this an abusive notation? The dot dot dot? It's fine. I'm not writing out every step of that. We do have to do the other part of the... Oh! Thanks for the follow, Ruhan. In the start, A is in C of A. Oh, you mean like I should have established that A is in C of A? That's fair enough. I was taking that as like obvious, I guess. But we can say it explicitly. All right, so if we let B be in centralizer of A cubed, or is that like to show they're not empty, I guess, as well? So maybe it's more important for like that reason. It doesn't matter? Oh, okay. And thanks for the follow as well, Moo. About the first version? Oh, okay, okay. Oh, I see. Yeah, I did say that A is in C. Okay, fair enough. This one I think is a little trickier, right? I remember doing this before. But what was the argument? Because we can't do the exact same trick that we did above with like, I think we can't at least, let's try it. Yeah, we get stuck because if we reduce it down to, we get rid of our A cubes and that's bad. So what was the thing that we do here? Do we invert each side or something kind of weird? We want to get that B commutes with just A. Oh yeah, do we what do we do? You use like middle cancellation or something that implies abelian, right? Like, do we want to look at like B A cubed B inverse? I don't remember. Multiply both sides by A cubed. Oh! We would do it from the first line? So if we left multiply by a cubed, what happens? Okay, a to the 6b equals a cubed b a cubed. And a to the 6 is the same as a times b. What do we do with ABBA, though? Mamma mia. If oh, it's a cubed commutes with b. I see. Okay. We want to bring the b over here. B a to the 6. So ab equals ba. So b is in the centralizer of a. Okay. Bam. I hope it's not being blocked by the problem. No, it's not. Okay. Nice call. Oh wait, shoot, Ruhan, you posted that question. I completely forgot that you did that. I'm so sorry. Let me scroll up and check. 'Cause you think it's cyclic? Okay. I completely forgot to look more at the question that you posted. Okay, so I just copy pasted the problem that you posted. Prove that any monotone function on an interval can have at most countable discontinuities. A monotone function on an interval can have at most countable discontinuities. Moo, yes. If you like straight up post a solution or something, I might say that I'll look at it later after I give myself a chance to think about the problem. But if I don't want people to put something in chat, I'll be like super specific about it. But like in general, if I'm not like saying anything, just kind of post whatever. And if it's like homework help, please post it. Like the algebra that I'm just doing for fun, you know, sometimes I'll want to try it for myself. But if someone like in chat comes in with a question like Ruhan has, I want to do things like the absolute like best way, or you know, like the right way. So that's what I especially appreciate, people like piping up in chat. If you have a solution for that one, Megalomorph, I would love to hear it, because I'm not sure so far. Like, would you prove that every discontinuity is a rational number? I don't know how monotonicity would imply that, though. I mean, it's not necessarily, it could be finite. So maybe the idea with rationals isn't good. Any monotone function on an interval can have at most countable discontinuities. The question, Moo, it's what I've put in chat just a couple of messages above. It's from Ruhan04, but that was like a while ago, so I just went and pasted it. Actually, I can put it on the screen too. So what I'm thinking is oh yeah, Jed, nice. We had the idea at the same time. Like, can you get in a monotone version of Dirichlet's function, I feel like that wouldn't be the worst thing to think of. And that would be, wouldn't that be a counterexample to the implication of the problem? Let's see what Megalomorph is saying. All the discontinuities of a monotone function are jumps. Sure. Does it have to be defined over the entire interval to be monotone? I mean, is that even necessary though? I mean, there's certainly jumps, I guess. I guess there could be a gap. But yeah, if you're monotone increasing, the next piece of the function after the discontinuity certainly has to be higher or lower. Or equal, I guess. I don't know. Okay, there are most finitely many jumps bigger than 1 over n. Really? For each n, and every jump is bigger than 1 over n for some n. What? Am I sorry what a jump discontinuity is? Okay, no, that is what a jump is. It's like, just to get an example of a function that would fit the bill is like the step function. If we only consider the interval like, 0 to 3, that's pretty finite. That's a pretty finite number of discontinuities there. And these are certainly jump discontinuities. All the discontinuities of a monotone, there are at most finitely many jumps bigger than 1 over n for each n. If you have the f of a equals 0 and f of b equals 10, there are at most 10 n many jumps bigger than 1 over n. Try to figure out what n is here, I guess. Y8. Is that related to the? Is that a separate problem that you're saying, Y8, or is this related to what Megalomorph is saying? No, oh, okay. No, you're good. What do you mean by minus infinity or plus infinity? Like their limit? Or like I'm not sure exactly what the question is there. Like the limit as x goes to infinity, or talking about a rational function that blows up to infinity, or? Oh, you mean like okay, sorry, I'm just gonna take a quick break for if you have like 1 over x, what you're saying is if you approach from the right, you're going to positive infinity, but if you approach from the left, you're going to negative infinity? It definitely can. They sometimes agree with each other, but they can be different. So like 1 over x is a good example of different, but if you want the same, 1 over x squared is your simplest one where they do agree. Awesome. Okay, back to the harder, or sorry, I shouldn't say easier or harder, but back to Ruhan's question and Megalomorph's response to it. Essentially, thinking about on the interval 0, 1 there, if there are only counting many jumps on this interval, then we can take the union. Are we given that it's countably many jumps? Well, I guess that's the entire question. Prove that there are countably many. And what about a function that goes up to infinity, though? Oh, on a fixed interval? Yeah, I guess. Can we say if it's like compact? If you go up to infinity, then you stay there, no more jumping. Well, I don't know. That doesn't make sense to me, but because infinity is infinite, so you keep on jumping. But I think you're more qualified to answer this than I am. But let me see what Moo was saying. So I'm just trying to understand it for myself. But I think it's I would trust people in chat more than I would trust me here, because my analysis understanding is very basic. So Moo is saying, let S be the set of all discontinuities. For every S, there exists a rational number between the left and right limit. Get a map of S to the rationals. Since F is monotone, this function is injective. Or yeah, compact interval is the wrong word, but how do we know there's a rational number between the left and right limit? There's a rational number in every open interval? When we say, okay, like it's the rational number in the x values or the y values, I guess, because what I'm confused on is if you have a discontinuity, right, it's say like, you know, whatever, if it's just like a jump continuity like this, rationals and y. Okay, so between like, in this example here on Desmos, between y equals 1 and y equals 2, I can still believe there's a rational number there. Okay. I think I'm an irrational person because I'm definitely dense. But we still have, you know, uncountably infinite numbers between 1 and 2. So let me read further in Mu's argument here. So we get a map. Oh. And S is just any rational number in this interval. Huh. Since f is monotone, this function is injective. Intervals are disjoint, yeah, because it's monotone. Okay, and that's how you explain the injectivity. Because of the monotonicity. Huh. Yeah, I think they're saying, I think Mu is saying a specific point, a specific rational number in that interval. Yeah, so I guess there's an answer in chat. This is like, it's very much at the edge of my like analysis knowledge, so I can't confidently give a response myself, but it sounds like there's a decent answer in chat. Oh, wait, there's a second question? Wait, no, this is just a question from Ruhan, who is presumably studying analysis. Oh, well, actually, yeah, it is for real analysis. Not for like Zach's real analysis class, but it's just a question from Ruhan in chat, who's asking an analysis question, I guess. Oh, I see what was happening with the second proof or not. Yeah, so I think I've unpacked Mu's proof, and I think it makes sense to me as well. Oh, that's not the important part. Megalomorphs, it probably works. I just have a hard time understanding it right now. So yeah, I think maybe I'll move back to algebra because I have a hard time commenting on the proofs. But yeah, Ron, I'd say that Megalomorph and Mu have both offered proofs that will probably be what you need. and if they're able to, or I guess like questions are probably better directed towards them. Not that they have to reply, but yeah, I think at least for me, there's not much more that I can like say about it confidently. But yeah, welcome in. And actually, I should say, if you're gonna need more help with math, I am not the only math streamer who's out there. Here's a whole list of them. Other people who I can recommend the highest. And if you're doing analysis, I will particularly steer you towards Zach or e to the 2y pi. The second person in that list there. So if you're not already aware of the people in this list, I highly recommend you follow them all, but if you're doing analysis, especially Zach. And that goes for anyone in the chat who's maybe new to math streams as well. Like, just check out all the people in that list. They're all awesome. They all have their own things that they're good at. My specialty is letting people in chat solve the problems for me. Complete agreement, but maybe I'm biased. Yeah. I think we are doing 47, right? Let me check Penn Center's thing. Yeah, 47 as well. How are the beans on toast? Okay, so 47. And also for anyone who's new in chat, this thing that I've been doing is part of an abstract algebra reading group hosted by Penn Center, who's also in that list. So if there's not a question from chat, this is what I've been filling the time with, studying out of this book here, and Penn Center has assigned some like problems that we're all working on. Oh, did I miss a part of 45? But yeah, as soon as someone asks a question, I kind of switch gears and work on that question. Oh, I did miss that for 46, yeah. Is one that we were working on. I completely forgot that there's a second part. Thank you for that, Fembox. It's only the full English. I only had that when we go out. So yeah, the second part of 46 here. Find an element A from some group such that the order of A is 6 and the centralizer of A is not the same as the centralizer of A cubed. So immediately, I don't think we can do like normal integer or real number addition or multiplication, because that's abelian. You want to name a non-abelian group. Like matrix multiplication? Like, what other tools do we have in our toolbox? Like, so the dihedral group stuff, I don't know if I want to mess with. Where's that whole like list of groups? Something with order 6 and the centralizer of A is not the centralizer of A cubed. Okay, here's our group cheat sheet. So these first 5, I think they're right out because they're just abelian. U of n is right out. Component-wise addition, that's out. So really we're down to GL, SL, and D. Unless we want to go off the rails and make our own group entirely, but I don't know how to do that, so. Oh, thank you for summarizing those. And the order of A is 6. That's going to be a pain to prove. That's what I'm thinking here. So maybe dihedral group is not so bad, because if you have a dihedral group of order 6, does that mean we're dealing with a 12-sided shape? Yeah. And what is your minimum, whatever the smallest rotation you can do, 360 over 12 is 30. Let me make sure. I think we actually do want to do dihedral. I feel like it's a bit easier to work out a power of 6, because doing matrix multiplication 6 times in a row is going to be, or finding a matrix of order 6 is going to not be easy. Let me just make sure that I'm remembering the dihedral group stuff right. So dihedral group of order 2n. Oh wait, so I had it back. I did have it backwards. If we want, d sub 3 is order 6, which means triangle. Really? There is no order 6 element, though. Yeah, so I think we need a hexagon here. Because in a triangle, the biggest order you have for an element is 3. Because the flips always undo themselves. The rotations, you know, your 120-degree rotation is order 3. So, oh wait, what about the 240-degree rotation? Bring it around once. 240 and 240 is the same as a 120. Which, no, that's order 2. 3. 2. 3. So yeah, I think we need a hexagon, Fedbox, you're right. So d sub 6, the dihedral group of order 2n, which is a dihedral group of order 12. It was the second part of 46. So I'm trying to figure out the simplest example that I can give for this thing here, and the only groups that I could think, it's like we need a non-abelian group here, I think. Otherwise this whole centralizer thing is going to be kind of pointless. And so the only non-abelian groups that we've talked about, at least in the book, are dihedral groups and GL, or like, you know, general linear and special linear group of matrices under multiplication. And finding a matrix of order 6 sounds kind of terrible. So that's why I've been focusing on dihedral group. So yeah, I was thinking dihedral group, I guess we're doing of order 12, and we're taking the minimum rotation. For a hexagon, you do 360 over 6 is 60. So are the things that commute with a 60-degree rotation not the same as the things that commute with a 180-degree rotation? I think that's basically the question, or that's what we want to hope for. Otherwise, we need a more complicated example that I don't know how we're going to get. D6 sounds like a good group? Okay. We're gonna have to make like a whole Cayley table or something. It's gonna be hard to figure out like what the centralizer of each are. I mean, we're allowed to find one element that's in one and not the other, I guess. So I bet the 180-degree flip is going to, or the 180-degree rotation is going to commute with a flip in a way that the 60-degree rotation won't. So maybe that's a thing that we'll focus on. Oh wait, are there only 3 flips? So we flip through this corner. Oh yeah, that's just a thing with even. Oh wait, I'm using F twice. I'm gonna say R for reflection maybe. Like these dotted lines are flipping across that axis. Why am I... R2 should be down here, shouldn't it? No, Oh my god, okay. R1 is up here. R2 is here. R3 is there. Okay. For Dn and R of order n. R is, oh yeah, shoot, R is rotation, S is, okay, I'm gonna do S for reflection because I'm gonna use R for rotation. Oh my god, dude. We need some more words that start with different letters for these dihedral groups. S1, S2, S3. So, we're gonna name our A as R sub 60, which means that A cubed is R180. And so I guess let's look at what S1 R180 is and hope that that's the thing that won't commute. So S1, we flip FE and BC. And then we do a 180-degree rotation. I need to actually draw this, unfortunately. So we're flipping, so F comes down here, and then F comes around 180, so it goes back up there. E goes over there, and it does 180? All right, does this just stay the same, except A and D are switching? Versus R180S. 1. That's probably why these will commute, hopefully. Because DNA still switch. And then these switch, but then they get flipped right back over. Okay. Whereas, so we'd say that S1 is in the centralizer of A cubed, but S1 is almost certainly not going to be in the centralizer of A. So let's look at that. So S1, we do our flip, and then only a 60-degree rotation. So we flip, F is right here, and then it goes into that corner. So, oh, but I haven't done, what is A? Oh yeah, R60. Goodbye, eraser. Okay. So f flips down, comes over 60. D goes there, A goes there, E flips over, comes down, B flips over, comes up. Wait. Yes. And then C goes right there. Okay. And now it's probably painstaking detail, but since I'm just learning this, I'm drawing it out in painstaking detail. Okay, so 60-degree rotation and then flip. Okay, so we're already, as soon as we even draw an A here, we're already not commutative. So we don't have to do any more work here. Okay. Oh, really? True in the first place? Oh, geez. Yeah, you mentioned streaming, Megan. I forgot to check you out. It's not like you haven't done it in a while, but if you ever do it again. Just give Teo cryptic crossword clues to try and work out. Oh gosh. I can't even do basic crosswords, so 18 months. Oh, okay. Fair enough. Well, either way, I'm following. Like with crossword clues, a lot of them like they follow patterns, right? Or there's usually like once you get experienced enough with them, you have a lot easier of a time figuring out what's happening. All right, so we have 47 to do also. Let G be an abelian group with identity E and let N be some fixed integer. Makes me with cryptic crosswords that people tell me this is the answer because, and I still don't believe them. It makes any sort of sense. Well, that's how I feel about like 90% of the proofs that I see, so. Practice makes perfect? Okay, fair enough. Let G be an abelian group identity E and let N be some fixed integer. Prove that the set of all elements of G that satisfy the equation x to the n equals E is a subgroup of G. So all elements of the same order are a subgroup. Really? Give an example of a group of G in which the set of all elements that's of G that satisfies the equation x squared equals E does not form. Wait, what? Don't these contradict each other? Or why is this not a contradiction? Oh, abelian. Okay. Thank you. Nth roots of unity? Oh, yeah. And if n equals 4, all things that's squared of 1 will also be there. Oh, true. Okay, so all things of that order and all things with order that divide n. Huh. Okay, I mean, I'm going to just start writing things and see where it goes. So we can still do one-step or two-step subgroup tests. I don't know if one will be easier than the other. Usually two-step feels a bit easier. G is abelian. N is an integer. Technically, we should consider 0 and negative powers as well, right? Have they named what our subset is? The set of all elements of G. Okay. Never do one step? Oh, really? Okay. There's one proof that it made perfect sense for me to do, but I think in most other cases I've always done two-step. I think they're fundamentally the same thing, I guess, but two-step is easier to think about. It's my impression of them. So I guess I'm going to call our subgroup H. How do we phrase this set builder? It's going to be all elements x of G such that x to the n equals E. Prove H is a subgroup of G. That looks like 6. H is a subgroup of 6. Not order 6, just 6. Okay. So we're going to need to use our abelionosity here at some point. You should have the new in chat. Okay. That's still a 6. I actually wrote a 6. So I was trying to make jokes about 6. G. Okay, so since e to the n equals E for all n, E belongs to H. So H is non-empty. Now we want to show, let's just go straight to two-step, I guess. Closure and then inverses. So for closure, let A, B belong to H, which means A to the n equals E, and B, this feels very familiar. I guess we had it with the odd powers for that other one. I can count to G. We all like joking about 6. Oh, I get it. Okay, closure is simple because we have abelian. We know that, or let's just look in a vacuum at AB to the n, and it'll conveniently work itself out. So AB to the n is the same as A to the m, B to the n by abelian, which equals E times E, which equals E. So AB is an H. We're closed. Now we need inverses. And inverses have the same order. So isn't this like simple? Oh, wait. N isn't necessarily the order. Be careful about how we phrase it. Let's say the order of A is equal to the order of A inverse is equal to M. M divides N by the definition of H. I think that's how we need to go about this. So A inverse to the N is equal to A inverse to the K times M, where K is some integer. Which is A inverse to the M to the K, which is E to the K, which is, oh wait, it needs to be N. Oh yeah, we're fine. So A inverse is an H. Okay, good. That's part one. Six factorial equal to 48? That's really not 48, but okay, I mean, counting 6 factorial will be hard. Or am I misinterpreting the factorial? Is the double factorial potentially something else? Yeah, I haven't gotten to morphisms yet, but let me read that anyway. If A is an abelian group, then the map x to the n is a homomorphism. The kernel of the homomorphism is a subgroup. Okay, yeah, I definitely don't get that because I haven't gotten there yet, but I do like to read it anyway. So it might trigger a thought in the future when I do study it. You're making an Anki deck with some of these problems and definitions. What is an Anki deck? You go down by 2 each time? Oh, I never heard that. Or I never have seen that before. My interpretation is like femboxes. It's like flashcards. Ooh, okay. That's neat, Phobos. Okay, so we've done the first part of 47. The second part, give an example of a group G in which a set of all elements of G that satisfy the equation x squared equals E. So here, the proof for the closure part relied on being abelian. The proof for the inverse part did not rely on it. So we should try to break the closure here. Time to assume that you remembered everything. Oh, nice. Group G, in which a set of all elements of G, the equation x equals E does not form. Moo, I'm not currently a student. I graduated with a bachelor's in applied math and a minor in computer science like 6 years ago now. Grad school is a goal of mine, but I'm not currently a student. Then you forgot everything? Yeah, I feel that. Oh. Oh. Excuse me. Did his third year of university with pot, he remembers nothing. Sounds about right. But he had a good time, though. Opium. Podium? Yeah. Tell the kids are smoking pot these days. Give an example of a group G in which a set of elements G is either the equation x squared equals E does not form a subgroup G. So we do have to name another non-abelian group. Because the reason this proof doesn't apply to groups in general is that we use the abelian part for closure. And so surely we can just take two matrices that are inverses and then name any other matrix. I mean, and I bet even like D4, they provided Cayley table for. We could find a counterexample in there as well. Actually, the more I think about D4, the more I'm not sure. Like, that might work. Oh, Dragon Not Found. I didn't even see you over on YouTube. Shout out to Evelyn. Sure. And person on YouTube whose name I can't read. Is this abstract algebra? Yes. This is something I've been studying while there's not a math question from chat. Just kind of to like film what was something that's like math-like. Consider the smallest one S sub 3. Like, wait. Oh, S3 is also D3. Okay. Let's go back to the question then. Triangle. So we would say R120 is not included in the subgroup because R120 is R240, which is not E. R240 is not included. R0 is included. I don't think D3 works. I think D3 is fine with this, isn't it? Because the flips are all self-inverse. And the rotations aren't included anyway. Oh, wait! You take two different flips, and then you get a rotation. I get it. Okay. Yeah. Because you take... The flips are all included. None of the rotations are included besides R0. So you take any two distinct flips, that's equal to a rotation. That's not R0. Okay, that's how we break the closure. Okay. Skipping 48 and going to 49. You flip, then you slide. I didn't even see that. You got a class to teach, so must run. Oh! Sounds good, Mega. Good luck with the class. And good commute to class. Ha! What if you flip-flop? Prove that a group of even order must have an odd number. A group of even order must have an odd number of elements of order 2. Oh god. An odd number of elements of order 2. Is that right? A group with an even number of elements must have an odd number of elements of order 2. Well, okay, we probably rely on something up here, right? I should be thinking about questions that we just, like, we just did this. Is this a Boolean, though? It's not a Boolean. Hey, SPQ. A group of even order must have an odd number of elements of order 2. If it was like 48, it might build into this. I don't know that 47 really builds into it that well. It might be worth thinking about 48 here, because I think it looks like 48 is like the primer to 49. So oh my god. Oh. Find elements A and B from reversals of the order of A. I feel like this is poorly phrased, but it looks like the question is, for part 1, name an A and a B with order 2 and that have AB order 3. And I think this will be a good situation to use mod arithmetic. Hey, Star SK. It has been a long time. I've been good, though. How about you? Okay, so part A, name a group so that A is order 2, B is order 2, but AB is order 3. So I think we gotta try doing some modular arithmetic stuff and just see what works. Like how many, if we look at I'm doing the soldier boy. U8 1 3 5 7. What's order? I don't think anything's order 2 here. You're good, Star? That's good to hear. Just doing some abstract algebra like studying while wait to see if anyone in chat pops up with a question. Is this actually a good dihedral group one again? Because it's really easy, like all the flips are order 2 in dihedral groups. So if you combine a flip and a rotate, you might be able to get order 3. Do you, yeah, well, I feel like with you, you never have things that are order 2, do you? 3 squared is 9 is 1. Oh, never mind. And 7 squared is 49 is, okay, never mind. I actually named, if you take a equals 3, and actually these are all order 2. What am I saying? Duh, yeah, just name a group of order 4. You're gonna have to have elements of order 2. Okay. I don't know what the heck I'm smoking. Let's just take a equals 3, b equals even 5, and what happens? These are both order 2. 3 times 5 is 15. Wait, any product of these is going to be order 2. So this is still a bad example. So we should name something... Okay, so U8 is a bad subgroup. What if we did... We need to allow for like maybe orders that are... Like we do U6 might even be a better choice. I mean, flips might also be a good plan too. Oh shoot, Star posted a question in chat. Let's see. I was like preferring to do modular arithmetic, but flips will probably work. Let me see what Star is asking about though. Evaluate f of x equals minus a cubed. I assume those a's are x's, but minus a cubed plus 6a minus 7a equals -1 and state the remainder. Practicing for next year, need help for this. The phrasing here is a little bit tricky, Star, so state the remainder. You're not doing, like, okay, let me... Here's how I'm interpreting your question. You have f of x equals -x cubed plus 6x minus 7, and they're asking you to evaluate with x equals -1. That's how I'm interpreting like what you put in chat, in which case we'd say f of -1 is equal to -1 cubed plus 6 times -1 minus 7. -1 cubed is -1. -1 is +1. 6 times -1 is -6. Minus 7 is still -7. 1 minus 6 is negative 5, minus 7 is negative 12. So the answer is negative 12, but I might be misinterpreting you. So if I am, please tell me. Oh, okay. So yeah, if it's multiple choice, I'd go with B for negative 12. The idea is wherever you see an x in the equation, you just put a negative 1 there. That makes sense? Okay, cool. No problem. Oh my gosh, I'm sorry. This might be my last problem for the day. See, I feel like dihedral groups are pretty valid here. I kind of want to... Okay, yeah, let's actually... If I want to use the Cayley table to give for D4 because I'm lazy and I don't want to make a Cayley table. The thing is, we won't be able to do... it'll only work for the first one because the order isn't big enough to get 4 and 5. Or wait, is it? It's dihedral group of order 8. So we might be able to get 4. So if we want, we need A equals 2, B equals 2. And we want to name a combination that gets us A times B equals, or the order of A times B is 3. So I noticed we want to use flips. I believe R270, no, order 3 is R90. Okay, R90 is 180. That's already 2 of them. No. So order 3 is going to be R270, right? Or no, no, it's nothing's order 3. This is order 8. It has to divide 8. It can help with it can help us get an A times B order equals 4. Because the order of R90 is 4. It can't help us with order 3 or order 5. It can help us with order 4. So if we can name 2 flips that get us to R90, like we can do D prime H. And those are both order 2 individually. And they multiply something that is order 4. Okay. Now we'll need a different dihedral group. We'll need 2 different dihedral groups for order 3 and order 5. We could do the same one if we go for order 15 dihedral group, but I'd rather not. Actually, that doesn't make any sense. You have to do order 30. Which I don't want to do. So if we want to go for a dihedral group, oh my god. Okay, I just want to look up a Cayley table. Oh god, what is A, B, C, D, and F? You can't do this to me, Wikipedia. Oh my, what is this? That's a character table. Okay. Dude, just give me a Cayley table, please. That is actually readable. Yeah. Okay. This is such a confusing graphic to me. Like, I want to know what the A, B, C, D, E, and F are. All right, you know what? Fuck this. I have the idea. I'm not doing this shit. Oh, but I'm doing this because 48 builds into 49. Nar. I mean, I could try to go back to multiplication mod, whatever, but I'm getting even lazier than I normally am, which is saying a lot. Ooh. Okay, so a group of even order let's see what you're saying, Pinbox. The old editions of the Galleon text had a nice little diagram that showed that the product of two distinct rotations in a dihedral group would produce a rotation. And you can always find two given rotations whose product would be the smallest. Interesting. Oh, okay, I was like, given two reflections, you could always find... Okay, that seems like a more significant result than whose product would be the smallest of the rotations. Interesting. And so in that case, you could definitely use that idea to like build up like I use D4 for B, you probably use D3 for A, and D5 for C. Would probably be the easiest way with getting the two reflections that multiply to the smallest angle, or the smallest rotation. And that smallest rotation will have order of the group. So that is like a clever way of doing it. I'm just too lazy to do the actual legwork and showing it. You know, I mean no write good or speak good. School for kids who don't read good. I forget where that's from, but I vaguely remember that reference. I'm thinking about 49. My brain might be crashing too much. A school for ants. That reference I get. Prove that a group of even order must have an odd number of elements of order 2. Like, is there some way that we're supposed to, like, we can't, they're not going to come in pairs because it's an odd number. Another way of saying is an odd number of self-inverse elements. Really? Which means that if it's self-inverse, that means the element and its inverse are both order 2, which would imply that it comes in pairs. So maybe the even order somehow... Well, we don't know that A and A inverse are distinct. Well, no. Yes. No. Yes? I don't... You kind of picture in your head, though, that you'd always be able to reflect an n-gon twice. We could end up being one vertex clockwise from where it started. It's too late in the math stream for me to be able to picture that right now, but I do believe it. I don't think my self-inverse idea is actually all that helpful. Because if A equals A inverse, that's actually not a pair at all. That's just still one element. Yeah, I'm not sure. I might just cut the stream off because I feel like I'm at the end of my ability to think for the day. So yeah, let's cut the YouTube stream off here. If you're on YouTube, I appreciate you, and I'll see you later.